So, nice to meet, welcome, and I hope you had a nice lunch. Today, Christophe and I will show you a cool road we've been able to play with and to go along in the past few months. So, we will emphasize on the in-between world and Pentest applied to microservice environments when they are mostly in Kubernetes, but can apply to other kind of setups. So, our road will be, first, what do we call the in-between world, the place where most of the vulnerability lies. Then we will see how we can capture such interactions. We'll see how we actually use that behavior within the context of pen testing. We'll then explain a bit more what is Falco, so the tool we use, and how to make the most out of it and how it is set up, which will be covered by Christophe. And last but not least, what it was nice for, what it was not adapted to, what we should or could have done differently, and conclusion for sure. So first, what is the in-between world? What we call the in-between world is when you have that kind of situation when one system is safe by itself, being it on the network side, on the file system side, but when two safe components are brought on the same machine or same infrastructure, then things start to get wild. So really try to remember this kind of schema, and the fact that two things might be safe by themselves, but when brought together, completely go wrong. So a few examples of that kind of issues are the following one. When it comes to file system, you can have servers that rely on the file system for the code, and when it's being coupled with a file upload, straight away, really often, it ends up in a remote code execution. Same goes if you have a system to drop keys or alter a file system, but in the meantime, you have ways to write secrets, keys, and more. On the network side, if you think about devices or software that help you to analyze a website, its feature, by design, is to take a URL and try to fetch it, which is legit business so far. When you have the same issue in a cloud environment, big up Ronnie if he is there, then you can have that kind of issue, and that can completely get your cloud infrastructure pawned, which is not what we want. Same, the two sides of the story are legitimate behaviors, but when brought together, it's up. You have parser inconsistencies and differences. So you have two parsers, let's say backend and reverse proxy. They act in a safe way, but when used along, you have tons of bypass. Think about the ... /, which is deadly. Issues with admin interfaces and code malleability. There are a lot of file formats, a lot of things we can play with that are features that are safe by themselves. Safe by themselves, but when used together can really hit the fan. So this is the way we tried to sum up the issues. What we call the in-between is when two process or two specific components try to interact with each other, and that's where things go bad. So it's all boils down to communication, which is most of the time, if not always, handled by the operating system. And how or what are the communication we want to have information on is everything related to the file system. So think about files, think about semaphore, think about internal concepts of how to exchange data between process. Think about the networking side, so everything that goes on your public or internal networks or even on the loopback, and sometimes the Unix sockets that are both network-ish and file system. And last, all the executive behavior, so which files are being run, which command, what's happening process side. So that's the big picture and what we will try to get. So to get that kind of information, we do have to rely on the operating system that will run syscalls. If you're not familiar with this concept, syscalls are, well, it's GreHack, it's low level. I'm quite sure most of you are, but still, just the availability to go from user land to kernel land and call like a huge master function that will do the heavy lifting under the hood. And we have just so many syscalls to inspect, instrument, triage, and see whether they are bringing valuable information to us or not. Small side note, we often talk about black box, gray box, white box, which is when we do have access to the source code, an account, or nothing. And you see, what we are trying to show is beyond this concept, because you can be in a black box environment and see nothing. You can be in a white box and have the code, and yet not have enough introspection or observability. And even though you are in white box, you can't know what's happening inside the system you are testing. Our main example for both of us, we work, well, this work was done at Mano Mano. We want to exploit things, but in the meantime, there are just so many microservices that we don't know at all sometimes what's happening on the operating system or offensive side. So this is really decorrelated from the two concepts. So now we know what we want to target, and we'll try to do so with a request. So this is WikiHow, if you're familiar with this one, and I just, well, for fun, wanted to give it a try. How to hook syscalls, please. Well, that was a nice surprise. The first results were with userland. So think about LD library, preload, hooking, and more, or Frida. The second one was with a kernel module. So you just load something in your kernel that will allow you to inspect every syscall by doing some hooking process. And the last one, which is most likely the most suitable for this research, is using eBPF filters, so we can straight away inspect what's happening within the syscalls that are being emitted by the system. And actually, that was a lie. Here were the results. So if someday you really want to hook syscall, but in the meantime know how to not have a camel toe, who knows? So the tool we really tried to play with was sysdig, which is not really open source, yet you can have a play with it. And if you're curious about that, tonight there is a workshop to use this tool. And so the main behavior is to plug into all the proc file system in the right places, to load the probe, the eBPF probe, and then be able to log all the syscalls. This is a sample result. So you can see on just below the green line, that we want all the events shown in ASCII form for the container named Ubuntu. And we will then grep to have only the exec, open, write, read behaviors. And voila, we just used one line, used the right tool, and by running the command who am I up there, we can see that a pseudo terminal is being used. We can see which command was run, what were the file load, and in which order. What really is interesting is that you can see the whole order of ld.so trying to then load libc and to map it and to read it, and then to see if we need to switch namespace, and even further try to read etc password. This, from an attacker point of view, is a gold mine. You don't have any setup, just paste one line and fuzz around until you see something that catches your attention and really yells, hey, exploit me, please. So this comes really handy when we are in the Kubernetes world. Top left is the pentest we are most of the time used to. There is one backend or two. We can have a few assumptions. There is some cache, maybe a reverse proxy. And voila, we can just break our Joomla, WordPress, Drupal, anything. And that's it. On the bottom right is the case we were into when we try to submit one or two requests and end up with just so many interaction that we are completely gullible and have no clue on what's happening within the infrastructure. Here again, we don't speak about the overall observability for stability, reusability, performance, but more on an attacking perspective. We don't know what's happening and which component we are reaching. So the main conclusion from that is that the more an infrastructure can grow big, or any software, we know for a fact that the number of bugs will always scale with the complexity. But with more complexity, it gets way and way harder to make assumption on, hey, what's happening? So we had to find a solution to still be able to do our security assessment, but not pick one microservice one by one. Currently, we have around 400 microservices. We are 2-ish pentesters. It's just no game. So we had to find another way. So here is the main TLDR for this first part. Big structures imply lots of bugs. Big structures also implies good luck with that. So we need to bring the sysdig powers or syscall grep power to Kubernetes. What if we already had that at hand? What if? Bring Falco to the cloud. So here is the big picture. We have sysdig on the top left, which is what we just showed, but it's mostly a beautiful front end for lib that lib. Well, the names, that also relies on libscap to have the whole process and IO right for the events we want to filter on, which then rely on kernel module or eBPF. Please pick eBPF, don't crash your prod. And so the small move that we did is that instead of using sysdig, which is, SaaS paid version of what we want to do, we use Falco, which is the open source, still maintained by sysdig and the community, of course, version of it, which is more of a SOC-ish software. But here, there is a real engine where we can say, hey, I want to monitor new files being created that end with .php. Or we want to monitor for polkit or sudo being run with specific arguments that we know for sure are exploiting attempts. So this is a SOC, but maybe we can turn that SOC into something else. Introducing Christophe.
Thank you. So on the previous slide, we've seen what is Falco. So let's dig a little bit on Falco, and especially Falco as a container. Falco is divided in two services. The first one is the agent. So this agent needs to be deployed on each node to collect all the syscall on the kernel and raise some events based on some rule that we define on the agent. The second one is the sidekick. The sidekick is like the router. It will get all the events from the Falco agent and forward to several system output like Datadog, Slack, a database, or anything else that you can store some events. There are some other services. This is optional. They are the Falco WebUI and the Redis. So the Falco WebUI and the Redis work together. It's just to have a nice view of the events that the Falco Sidekick will receive. Let's translate on Kubernetes. Like I said just before, that the Falco agent needs to be deployed on each node. So we will use the daemon set. It's Kubernetes resources available on the kube that it will handle the deployment on each node. For the Falco Sidekick and the WebUI, we just deploy as a replica set another resource on Kubernetes. This resource will just handle that the service will be deployed to pods just to ensure that the service is reliable. How to deploy on Kubernetes? Like most of the tool to deploy on platform, we will use a package manager. For the Kubernetes, the package manager is called Helm. It will use some file, a collection of files, to deploy all the resources that is required for Falco to deploy on the Kubernetes. In our case, it's the daemon set, the replica set, the config map to store all the configuration, and the service account because you need some access to the Kubernetes. How the Helm is working, you have the template, which will describe all the daemon set and the information, and some variable in a value file, and the Helm chart will merge both and deploy the required on Kubernetes. Actually, the Helm chart will deploy all the configuration, the rules, the service, and the containers. We would like to split, in our case, we would like to split the service deployment from the rule deployment because it's not the same life cycle. And we would like to update much more often the rule that you want to deploy the service. So for that, we will use another templating tool. It's called Customize. This tool will just update the manifest that we deploy in Kubernetes just before applying on the Kubernetes. And with this, we just tell to the manifest, say, okay, let's create another custom config map and let's create just an empty one. Thanks to that, we can after create and update the config map with all the rules that we define in YAML file, and we split the deployment, between the service and the config rule. Notification. Sidekick will receive the events from the Falco controller and push to any other service like database, Datadog, or anything else. In our case, we decide to send the events in two different services, the Slack for the immediate alerting, and Datadog to have an SRE and creating some statistic from the events. And at the end, we have a nice dashboard on Datadog with all the events and metrics from the Falco. Here we can see that we have the memory, the CPU usage from the Falco, but also on the alerts raised by Falco on our infrastructure.
Demo time. So we are not as ballsy as some of you, so it's recorded one, mostly because it requires network interaction. Okay, so here is same screen, same UI. We can see on the top part that we do have a bash script that is mostly 100-ish lines, and that's all we need to benefit from Falco and turn it into our fuzzing introspection tool we always dreamt of. So we execute this one. First, we will be asked to pick the cluster we want to introspect. So this heavily relies on the tool called FZF to have fuzzy find at hand. First, we pick integration, of course, because we don't want to break production again. Then we will pick a specific microservice we want to introspect, and then we are prompted with all the rules that will be sent away. It's still a SOC, but we just say that we want to be alerted on pretty much any kind of event and with any kind of value. So it will just, yield a lot of issues, but not to Datadog nor Slack, just to our standard output. So we give it some time. On the top pane, we were prompted to select the container. So within a single Kubernetes pod, which is one contained action, we do have many containers. We can have the main one, we contain the application, we can have secrets management, we can have proxying, observability, and more. So I picked the main one, and we are given with this view. First pane is all the Falco logs to see if nothing broke while we are still using it. Second one is a shell that is being offered to the pentester or SRE that is being using the tool. And the three last one are the parsed and beautified logs from Falco and split as we begin with by file system, network interaction, and execution behaviors. So if we just leave it some time, first it's not inserted yet, and then we start to have some results. We executed the command ID. We see on the last one that we do had some commands being executed. So we can't see the ID yet, but it was observability being run at the same time. On the past previous pane, we can see which files are being opened. And give it some more time. You can see on the last one, the user data use bash to list something. We can see which file being sent were being opened, and here we can see all the internet traffic from the machine. Kind of like T-Shark, but more convenient, and you can have filters for all the kind of events with the same approach. We don't have to rely on many tools at the same time. So here, first thing to see easily are some get calls to readiness. So is our pod available? There is on the last line our curl if config being sent. So if we are trying to dig for SSRF or interaction cross machines, it's just below our eyes. We can just grep or save the logs and dig later. Here's beautified. The main output is JSON. So with JQ or anything, you can filter on whatever thing is of interest to you. And here, when we do run our command, we see the whole flow of files, libraries, configuration files being used. So one thing that we often miss is files that are not existent on the file system, but are still trying to be opened and not found. Here, we have our superpower, and we can just see if we do have a writable path that with files that are being used, but not present, we could overwrite or write append to alter any program's behavior and try to gain code execution that way. And same again, we know which process modified which file, when, and what were the actions that led to this action. So that's it with just // in a small bash file and 3 rules. We brought our superpowers to Kubernetes. That was for the demo. And now that we know what we can do and how easily it can be leveraged, how to do things the right way.
Thanks. What does it cost to run Falco on our infrastructure? How does it cost in money and also in time? The first thing is the resource overhead. Because you deploy Falco on our Kubernetes, you will consume the resource, so the CPU, the memory, the network, but also the storage, because Falco generates some logs and events, and this event and the logs, you need to store it. You need some time also because, like most of the tools, you need to learn how to use it. You need to train because Falco comes with some general rule, but you need to create some custom one specific for your environment. To deploy it, to set up the alert, to keep Falco up to date, it will take time also. And to integrate with your infrastructure, so the monitoring, the security access, so everything like that. Some limitation. Falco read the syscall from the kernel with eBPF and the feature and the kernel. Sometimes this feature is not available or not well set up on your infrastructure. Falco read the syscall, like we said, on the node, so it's really limited scope. If your infrastructure have some database outside your cluster, you don't see any call on this, you just see the service calling the database. You need also to customize the rule to match your requirement. Falco comes with some generic rule, but it's not set up to your specific need on your environment. So you need to customize it. Because you customize it, you can have some false positive, like many of monitoring system. And this had some complexity because you need to spend time. The performance impact, Falco need to, like you say, use some memory and resource. So you need to limit properly to avoid performance impact. And is it a community tool? So you don't have the same support level that if it's commercial tool. What did we learn with Falco? The first thing, when we deploy Falco on our infrastructure with the general rule, we have seen that many services have some specific call, and thanks to that, we have a nice picture on our infrastructure. So the socket open, the several call, all the things. And so then we decide to create some custom rule, and this custom rule help us for some project. The first one was the migration on AWS from the EMDS v1 to MDS v2. So thanks to that, we can follow the migration and all the services still using the v1 instead of v2. As a monitoring tool also to check all the sockets, the weird socket, the web shell, and all the detection that any event that we say is weird for us. And for the red team, because with Falco we can see all the requests, so when we do infusing, you can see what happened. Some instabilities. Falco is a nice tool, but you have some bad effects. The first one that we had is some feature consume more resources than the other one. So sometimes you have some overhead. You need to be careful of that. Falco will read the syscall and generate some log. When you generate some log, you have this call because it's right inside the file or in stdout. But if you don't tune the rule correctly, Falco will catch the rule generated by the log, and again, and again, again, and again, and we have the length test. Falco needs also some external module to read the eBPF, so it can be dangerous to load, especially for production environments. On the kernel older than 5.8, the eBPF is not easy to access. You need some privileged access. So it's pretty dirty that you set up privileged access on one services to access the syscall. And all the thing had some complexity to deploy the service. On our monitoring and on-call. The thing that we have also is the Falco can add some more alerting monitoring for some events, and we also have an historic of all the events that happen that can be useful, especially when we have an incident, so that you can check all the steps they had before the incident and maybe if it's related or not to our incident. It's also useful to reproduce the incident because you have all the events stored in, for our example, in Datadog.
Small pre-conclusion before the conclusion. What I understand from what he said and we discussed about is that this tool is huge, allows you tons of benefits, but it's quite still easy to shoot yourself in the foot, both for stability, performance, and sometimes cost. So do that. It will help you sometimes at your own risks. Now the real conclusion. For the pentester side, first, you will finally try to hit an application and not be blind to what you are doing. If you have a code execution or close to code execution, you will know that for sure. If you have a file write or a modified file, you will know what you are dealing with. So it makes things way, way more happy to play with. It's a huge time gain because same again, you don't have to set up any debugger. You just have all the information you need at hand, which is super convenient, and you will cover a way, way wider attack surface. Think back to the beginning of this talk with all the microservices and the whole schema. What happens is that you can send a request and hit your first backend or first microservice and just be totally unaware that the third, fourth, or fifth microservice you are targeting with redirects and exchange being just consequences of your first action. Now you can know that you have 5, 6, 10 server further file write or an SSRF, or maybe you already have code execution. You didn't know, now you do. And for the company-wise, well, you do already have a small yet efficient SOC for both security aspects, but also to enable you to make run migration and know which components are not acting the way they should. You do have a way to diagnose pretty much any infrastructure-related issues quite easily. You just // and you have your magic glasses again. And last but not least, you are a company, so if you do run pen test campaign, you will pay for that. And so it's always in your interest that pen testers will be able to make the most out of it. If you just offer them black box, they can't do much. If you offer them a black, white, gray, pick your box, but with efficient logging, they will be able to get way, way faster into breaking your infrastructure, helping you to then harden it. Unless you don't want them to break it, then it's your choice. That's it for our presentation. We hope you liked it, and see you tonight for the workshop if you picked the SysDig one. Cheers.